Dear students, welcome back to the e-learning course 4, Derivatives and Risk Management. In lesson 2, you will get an introduction into forward and futures markets and learn the mechanics of trading in these markets. Moreover, you will get an understanding why these contracts are useful investment vehicles for both hedgers and speculators and how the futures price relates to the spot price of an asset. Finally, we study how well the futures price forecasts expected future spot prices. The learning goal of this session is to introduce you to the main principles of forward and futures contracts. Futures and forward contracts are like options in that they specify purchase or sale of some underlying asset at some future date. The key difference is that the holder of an option is not compelled to buy or sell and will not do so if the trade is unprofitable. A futures or forward contract, however, carries the obligation to go through with the agreed upon transaction. More specifically, a forward contract is a commitment to exchange an asset at a future date T, called the settlement date, at the price agreed on today. A forward is a customized contract between two parties called counterparties. Since forwards are not traded on a centralized exchange, they are therefore regarded as over-the-counter instruments. While their OTC nature makes it easier to customize terms, the lack of a centralized clearinghouse also gives rise to a higher degree of default risk. As a result, forward contracts are not as easily available to the retail investor as futures contracts. Let's consider a short example of a forward contract on heating oil between northern refineries and Arctic fuels. Suppose the forward price of $2.40 per gallon is fixed today, but payment and delivery occur later in the year, say in December. In this context, Arctic, which has agreed to buy in December, has the long position in the contract, while Northern, which has agreed to sell in December, has the short position. You can think of this in balance sheet terms. Northern starts with a long position because it will produce heating oil. Arctic starts with a short position because it will have to buy to supply its customers. The forward contract creates an offsetting short position for Northern and offsetting long position for Arctic. The offsets mean that each counterparty ends up locking in a price of $2.40, regardless of what happens to future spot prices. However, as already mentioned before, both the distributor and refiner have to worry about counterparty risk. That is, the risk that the other party will not perform as promised. So far, we assume that Northern and Arctic had to negotiate a one-off bilateral contract and do the trade done. However, it is also possible to go to an exchange where standardized forward contracts on heating oil are traded. In such a case, Northern, as the producer of heating oil, would sell a contract, and Arctic, the distributor of heating oil, would buy such a contract. As you might already suspect, an exchange trade standardized forward contract is called a futures contract. The distinction between the futures and forwards does not apply to the contracts itself, but to how the contract is traded. Another characteristic we will have a closer look at a bit later in this course is that futures are settled daily. You might wonder, what do we mean by a standardized futures contract? Futures contracts are standardized with respect to underlying asset, which might be a homogeneous commodity of a standardized type and quality, or a financial asset. Moreover, each futures contract must be for a standardized quantity. Futures contracts must be in a single currency determined by the location of trade, and futures contracts must have a standardized delivery date. Well-known futures exchanges are the New York Mercantile Exchange, the Chicago Mercantile Exchange, or the Chicago Board of Trade. Another important characteristic is that futures contracts are marked to market, which means that profits and losses on the corresponding position are settled daily. For that purpose, a margin account needs to be set up with the exchange. The margin serves as collateral and consists of cash or treasury bills and demonstrates that you have the money to honor your side of the bargain. In session 2.2 of this course, we will talk about margin accounts in greater detail. The following table lists a few of the most important commodity futures contracts and the exchanges on which they are traded. You recognize that there are, among others, futures contracts on corn, wheat, soybeans, coffee, lumber, or even live cattle. Financial futures are similar to commodity futures, but instead of placing an order to buy or sell a commodity at the future date, you place an order to buy or sell a financial asset at the future date. Futures can be traded, among others, on currencies like the euro or the Japanese yen, on equities or interest rates. Almost every day, some new futures contracts seem to be invented. One example are futures contracts on the weather in 24 US cities offered by the Chicago Mercantile Exchange. These contracts are used by organizations to hedge or mitigate the risks associated with adverse or unexpected weather conditions. Typical users of weather derivatives include farmers to hedge against poor harvests caused by frosts or low rainfall, and energy companies that may use weather derivatives to smooth earnings caused by unseasonably warm or cool temperatures. Panel A is a plot of the profits realized by an investor who enters the long side of a futures contract as a function of the price of the asset on the maturity date. Unlike the payoff of a call option, the payoff of the long futures position can be negative. This will be the case if the spot price falls below the original futures price. Panel B is a plot of the profits realized by an investor who enters the short side of a futures contract. It is simply the mirror image of the profit diagram for the long position. The distinction between futures and options is highlighted by comparing panel A to the payoff and profit diagram for an investor in a call option with exercise price K, chosen equal to the futures price F0. As you recognize, the futures investor is exposed to considerable losses if the asset price falls. In contrast, the investor in the call cannot lose more than the cost of the option. Finally, it is important to notice that any futures contract is a zero-sum game, meaning one counterparty achieves a gain while the other faces a loss. In other words, this means that gains and losses net out to zero. Now let us look at an example where a futures contract is used for hedging. As you might know, Kellogg is a large producer of breakfast cereals, and a major component and therefore cost factor is sugar. When the company is budgeting its sales volume and revenues, a fixed selling price is applied. However, changes in cost can impact these forecasts substantially. As a company producing cereals, you would like to fix your sugar costs by purchasing all your sugar today, since you like today's price and all your forecasts are based on it. But how can this be achieved? The answer should be pretty obvious by now. You sign a futures or forward contract to purchase sugar at various points in the future for prices negotiated today. The term hedging refers to the technique of managing your sugar costs. In this example, futures and forwards are used. However, you can equally well use call options for that purpose. In this context, it is important that you are aware of the relative benefits of each instrument used to achieve your hedging objective. After having carefully studied session 2.1, please start with the review questions.